Hi, I'm Amir Hossein Mirza Bozorg, and in this video I want to talk about the impact analysis in Abacus. This is the table of content. I will talk about the Abacus structural solver's capabilities in impact analysis, types of impact, simplifying assumptions in impact analysis, types of contact, and finally discussing the results of two impact simulations. Impact simulation contains large deformations, contact, and plastic deformation, and probably damage initiation and propagation. As you can see, we have all of the sources of nonlinearity in the impact simulation. So, impact simulation is highly nonlinear. I want to talk about an example of an impact analysis. Here, I have simulated half of a model. This is the projectile and this is the target. As you can see, there is contact between them, and because of the impact, there is large deformation in the target. Usually, the lateral faces of the target are fixed. In this simulation, damage has been occurred in both of the target and projectile. I want to talk about the Abacus structural solver's capabilities in impact analysis. Both of the Abacus structural solvers can solve nonlinear dynamic problems. If you want to use Abacus standard solver, you must use dynamic implicit step, and if you want to use Abacus explicit solver, you must use dynamic explicit step. If the kinetic energy of the projectile is relatively high, probably damage will occur in both of the projectile and target, or in one of them. In this situation, because of the complex contact between the target and the projectile, dynamic implicit step will not be able to simulate the problem completely and will encounter convergency errors. For simulating such nonlinear dynamic problems, the only choice is dynamic explicit step that uses explicit algorithm for solving them. Actually, dynamic explicit step is well suited for solving the most sophisticated impact problems. According to the velocity of the projectile, we have two types of impacts: low velocity impact, or LVI, and high velocity impact, or HVI. In LVI, usually the projectile doesn't pierce the target because the kinetic energy of the projectile is relatively small. And in the HVI, usually the projectile pierces the target because the kinetic energy of the projectile is high enough to pierce the target. Here, I want to talk about the simplifying assumptions in impact analysis. If the Young's modulus of the projectile is much bigger than the Young's modulus of the target, For the sake of simplicity, the projectile can be defined as a rigid body. Good agreement between the simulation results and the experimental results shows that this is a proper assumption. Or if the Young's modulus of the target is much bigger than the Young's modulus of the projectile, we can assume that the target is a rigid body. There are two choices for defining contact between the projectile and the target. You can use general contact algorithm or surface-to-surface contact algorithm. If damage occurs during the simulation and if the projectile is assumed as a rigid body, both of the surface-to-surface contact and general contact methods can be used for defining contact. Or if damage occurs during the simulation and if the projectile is assumed as a deformable body and if damage only occurs in the target, both of the surface-to-surface contact and general contact methods can be used for defining contact. If damage occurs during the simulation and if the projectile is assumed as a deformable body and if damage occurs in both of the projectile and target, only the general contact method can be used for defining contact. At present, I want to discuss the results of two impact simulations. I go to the Abacus software. As you can see, this is half of the model and I have used symmetric boundary conditions for the projectile and the target. And both of them are assumed as deformable bodies because they have the same material. So we cannot assume one of them as a rigid body and the other one as a deformable body. You can see that the projectile penetrates the target and damage is occurred in both of them. In another simulation, I have assumed that the projectile is rigid. If you assume that the projectile is rigid, it's better to model it completely. But like the previous simulation, I have modeled half of the target and I have used symmetric boundary conditions. I have assumed that the Young's modulus of the projectile is much bigger than the Young's modulus of the target. You can see the difference between two simulations. In the modeling process, the only difference between two models is the material and rigid constraint of the projectile. Here, projectile is deformable. Here, the projectile is rigid. And you can see the difference in the pattern of damage in the target. And all of the results will differ. In this simulation, I have used general contact algorithm and I have defined internal surfaces for the simulation of contact because damage is occurred in both of the projectile and target. But in this simulation, I have used a simpler form of defining contact because the projectile is rigid and I have defined the surface-to-surface contact between the target and the projectile. You can contact me by using Telegram and WhatsApp or sending email. And these are our services: one-on-one tutoring on the AnyDesk software, WhatsApp, and making special videos to your order. And we can perform high-quality simulations for your thesis, exercises, and your industrial projects. Thank you so much. Goodbye.